Carrying capacity is 2. 3 cannot live. Carrying capacity is 2. She dead. Carrying capacity is 2. So when 3 come, 3 die. 2 can live here. Only 2 because of carrying capacity.
My braid almost done yet, Kayla?
Yeah.
Does that look good, Petra?
No.
Kayla! Did you see that person's science project the other day?
It was terrible. It's so bad.
Take your seats, students. The bell has rung.
Anyways. Yeah, it was so bad. It was crazy. Like this braid.
All eyes. Melissa, stop talking.
Sorry, miss.
Journal presentations?
No.
Wait, I can go and like know something like sciencey kind of, but I don't have any information about it. But I can still do it.
I have to have the written.
But I don't have that.
Well, I guess you can do it tomorrow. Anything for discussion? Yes, Melissa?
Okay, I had a really weird dream last night. So I had this dream that there was like these 2 like apes or cavemen, I couldn't really tell, and they were going like they were really happy because they found like food, and there was like 2 oranges, but then like their little baby came in and was like, I need food, do you need food or whatever, and then they're like, well, we only have carrying capacity for 2, and you can't come because that would make us 3, so like they ended up.
Are you sure you were listening in class? Or was that what your dream was? Because we did carry capacity yesterday.
Carrying capacity? Well, I guess
Melissa,
it's
did you fall asleep during class?
yeah.
If you would have listened in class, you would have known that the carrying capacity is the size of a population that can be supported indefinitely by the available resource and the surface of an ecosystem.
So there was only room for 2. 3 came. 1 died because 2.
Because there's not enough food and not enough shelter.
Then why would
That's
they
right, Kayla.
See, I listened in class yesterday.
That's
Well, then why would
good.
they have a baby if they can't feed it, Kayla? Like, it makes no sense.
You know, sometimes dreams are weird. It probably didn't happen like that. You don't remember it.
I do remember because it was weird. So I remember.
Okay, so now let's work on our induction today.
Not again.
Okay.
I've been doing this for like a week.
I want you to get it down pat. Listen. So, groups of 3, you can take, okay, not yet. Go back to your seats. Okay. Groups of 3. Groups of 3, and you can take an electroscope and 2 materials and see which one is negative and positive. Go.
Where are the electroscopes?
You have to figure that out on your own. Since you guys been so good for the last couple of days with induction, I'm going to show you a video from one
Induction!
Oh.
I hear they're good.
Petra, can you come get this for me? I can't reach it.
Actually, heard they're pretty good.
If I was your electroscope, I'd always be charged. Positive or negative, it'd always show. Take a charge rod and put it to the scope. Let the protons or electrons flow, and there you go.
Charge, can do. Positive or negative, it's up to you. I don't know about me, but I know about you. So say hello to induction in 3, 2, sweat.
I'd like to be your Mr. Shea. Hey students, let me teach to you. If I was a teacher, I want you to know charging by induction is not that hard to show. I could teach you charges, get your materials. If I was a teacher, I want you to know. I want you to know.
Now that you have attached your grounded wire, wait a little while for the electrons to go. Now detach the grounded wire so you can take a new charge. I'm gonna remove the rod like I'm laying in the snow. Burr.
Students, you could be my students, you could be my students till the class ends. Take away the wire, then the rod, now the leaves are open cause they're finally charged. Swaggy.
I'd like to be your Mr. Shea. Hey students, let me teach to you. If I was a teacher, I want you to know charging by induction is not that hard to show. I could teach you charges, get your materials. If I was your teacher, I want you to know. I want you to know.
So give it a chance, cause that's all you need to know.
Spend a class with us, you'll be charging by induction.
If I were your Shea, I'd always let you know.
Charging by induction, so much fun.
Na na na, na na na,
Na na na,
yes science. Na na na, na na na,
na na
if
na,
I was a teacher. Na na na, na na na,
na na na,
yes science. Na na na,
na na na.
If I was your teacher.
Just in case you missed anything from our video, here's a summary of what you need to know about induction and carrying capacity. Charging by induction is a method of charging a neutral object using a charged object without establishing physical contact between them. Let's say we were to charge an electroscope negatively. Here's how you do it.
As you can see, the drawing on your left represents a neutral electroscope with its leaves down. But if the electroscope is neutral, how does it become negative? Well, that's what we're going to find out today. Here's the next step. To make this electroscope negative, we're going to have to use a positively charged rod. All the protons in the electroscope will be forced to the bottom, and the neutrons will be forced to the top, since the rod is pulling them forward. Great job so far. So now that you've charged the electroscope negatively, the leaves will move apart since it's charged. Now you'll want to use a grounded wire that is attached to the electroscope. The electrons will distribute themselves over the electroscope, which will make the leaves neutral again. And there you go, that's charging by induction. Hopefully one induction taught you something, but if they didn't, I hope you learned from this. Now on to carrying capacity. Carrying capacity is the maximum population size of the species that the environment can sustain indefinitely, given the food, habitat, water, and other necessities available in the environment. You might not have understood Melissa's dream, but what was happening is that the green hose represented their habitat. Inside their habitat, they only had enough food, water, etc. for 2 people, so Melissa could not fit in. To give you an idea of how this would work, let's say that Petra and Kayla are hares. Most hares have 2 litters and some may have several. The gestation or pregnancy lasts 30 to 42 days, and 1 litter usually consists 8 babies. Now hares can reproduce quickly, so if Petra and Kayla had a bigger habitat, Melissa could have joined in and she wouldn't have to die. Having a bigger space for Kayla and Petra to live in would mean that they could reproduce and actually live because they would have enough food for their whole species.
If they did not have enough room, not only Melissa would die, but they would die too. That would mean that they would not have enough room for their litters as well, because they would reproduce. Since they would not have enough room, that would mean that they would not have enough food either. So they're over their carrying capacity. That would mean that their species would go extinct due to lack of space, food, water, etc. Thank you for watching. I hope that you learned a lot about carrying capacity and induction through this video.